Okay, I think we can get started.
Hello, folks. I assume everyone can hear me just fine in the back. So there was a little bit of an interesting mix-up. I had a 50-minute talk tomorrow and a 50-minute talk today and a 40-minute talk tomorrow because of my error. This is actually a 40-minute talk, and tomorrow's talk will be interesting. So I'm going to go ahead and take my time with this talk. If you have any questions, I will have plenty of time to answer them, so feel free to interrupt me while I'm going through here. Tell me what an idiot I am or whatever. Not a problem.
Do we have a heckling license?
Not you. But thank you. So, test class Moose. I wrote this primarily because people kept sending me emails saying, how do you use test class with Moose? I've done a huge amount of work with test class over the years, contributed a lot of patches to it, and it's a lovely module, but it's beginning to show its age, like much of the Perl testing tool chain, and it was time to bring it into the 21st century. So, for this particular talk, if you're actually going to try the examples, you want at least test class Moose version 0.12. You need to have a little bit of knowledge of testing. A little bit of knowledge of Moose would be helpful, though it doesn't have to be extensive. It helps if you know test class, but it's not necessary. For those of you who are not familiar with test class, but you are familiar with XUnit style testing, you got most of it right there. So, first of all, why would you want to use test class Moose? A lot of this applies for why you would want to use test class. So, if you have a lot of object-oriented code, as much of us do, having object-oriented tests fits very well with that paradigm. They mesh very nicely. It gives you a very nice performance boost, particularly in larger test suites. I've had cases with very large test suites taking up to an hour to run, and by combining all of them into a single process, it drops down to around 20 minutes. I mean, if you're loading Catalyst, DBX class, Moose, and a lot of other heavyweight modules again and again and again and again for every single .t test, that's a lot of time you're wasting. It also makes it very easy to organize your tests. We'll see a little bit more about this later, but I usually prefer the style where each test class has, or each class has a well-defined test class associated with it. So whatever editor you use, Vim, Emacs, Pico, whatever, you can write some sort of editor util to pop back and forth between them. Makes it very nice. If you already use Moose, then this is a no-brainer. You've got all the power of Moose built directly into your tests, and if you know Moose and you know how to take advantage of the power of Moose, particularly with a lot of the stuff with roles and meta information, then this is perfect for you. Most importantly, and this is the thing which a lot of people aren't familiar with, if you have very large test suites, you find yourself in cases where you want more information about your test suites. Which of my tests run fast? Which of my tests run slow? Great, I've just lost my network connection. I'd like to run my entire test suite and skip the network tests. If you need that sort of control, if you need that sort of information about your test suite, it's hard to get with our fairly old testing methods. Test class Moose gives you all of this. If you don't like this, you can also look at test routine and test ru. Those are based on Moose and Moo, respectively, to allow you to write .t style tests if you feel more comfortable with those instead of test classes. Oops. So, if you are not familiar with test class, but you would like to get some familiarity with it, I wrote a 5-part tutorial for it on Modern Perl Books a number of years ago. This is out on SlideShare, this particular presentation, a slightly older version under test class Moose, my name, Ovid. So you can find the links right there, or just go to Modern Perl Books and search for test class. You'll find the tutorial. It's a bit out of date in a few places, but it will explain to you why you want to use test class in a much deeper level than I'm going into right now. And it will also explain this curious little thing of what a basic test class would look like, a base class would look like for test class. And you wind up with a lot of boilerplate here. And people look at this, if you're very familiar with test class, you understand why a lot of this boilerplate is here. I don't like boilerplate. I want all of that to go away. That's why I released test most, that's why I released test class most, sort of a precursor to this, because I hate the boilerplate. I don't want to keep typing it over and over again, but I do. So this is what our new base class looks like with test class Moose. So a lot of the test control methods, which I'll be explaining later, those are all gone. You don't have to worry about those. I'll explain this auto use role, but no, we have a role there. There is proper moose, there's no tricks or hacks. That's not quite true, but hopefully you won't notice. And this is the driver class. This is what drives everything for, I'm standing in front of this. This is what drives everything in the test class moose world. You have a single driver script, call it what you want. You can write separate driver scripts if you want to. I don't like to, but I won't go into that right now. Unlike test class, we actually have a proper constructor right here. Why isn't there? We actually have a proper constructor right here. I won't explain what all of this is, but you can guess what some of this does. Showing you timing information, randomizing the order for tests, getting statistics. And also, we have this test report down here, something you don't get with any other testing system available in Perl today. At least not out of the box. So, enough about all the precursors. Let's talk about actually having something to test. If you're familiar with Moose, you already know exactly what this is. It's very simple. We're creating a person with a first name and last name. Very simple attributes we have up here. Read-only string, and it's required. And then you have a full name method, which simply returns first name, last name, joined by a string. And yes, I know there's a lot of issues regarding how names actually work in the real world, but this is a simple example. And here's what a test class for this would look like. You have your declaration at the top. I like to use the declaration tests for, : as a prefix on my class. So it reads very naturally. This is test for person. You know exactly what the tests are for. Very simple. I'm going to explain the auto use in just a moment. That was that role we saw earlier. We have a test constructor method. Every method which begins with test underscore is a reserved method. We use attributes optionally in test class use, but unlike test class, they're not required because I wanted attributes for other things, and I want this to be very simple to use. You just have test underscore, and you know that's a test method available for you in this system. We create our person object. Every test method gets a test object, which is self, effectively, a report object, which we'll discuss briefly later. Create our person, we just write some code to test it, and everything's fine. Aside from a little bit of extra work, this looks almost exactly like normal testing. Almost. You'll notice a few interesting things about it. Such as, so this test for person prefix I talked about, I have deliberately hard-coded the class name right here because I want you to see a very common failure happening with XUnit style tests. I don't want to get this out of the way right now, but you can also see how we can dynamically return the class name right here. But what's that auto use? Auto use was a role that I showed you. It's included with test class moves that I showed you earlier. Basically, whatever prefix you have, that prefix is stripped, and then it evals this class and class name. You don't have to use the class. It's automatically available, and the class name method returns the class you're using. So that's just a little bit more boilerplate because every single darn test class, you know, we've got up here. Do I show this on the next slide? No, I don't. I actually showed this on a few slides back. Oh, did I delete that slide? That would be embarrassing. Yes. At the top of all of our classes, I get really tired of doing all of this. We have our use strict, use warnings, test acceptance differences, deep, warn, whatever, and then use the person class. You see this over and over again in your test code. You don't have to do any of this with test class moves. It's automatically provided. The extra testing modules, if you're wondering about them, they're the same things available in test most and test class most. Basically, I did a heuristic analysis of CPAN. I've updated this a couple of times, and I found out these are the most popular testing modules, the one that people want. You don't have to use them anymore. They're just given to you, free of charge. So coming back here, so auto use over there automatically causes the test for to be stripped off, the person is used, and we now have that available, and you just, instead of typing use this, use that, use the other thing, you just sit down and start writing tests. And the batteries are included, as I mentioned. So is it okay, is there, eq or diff, all sorts of other testing functions. They're just built in. Again, you just sit down and you just start writing tests and forget about all the boilerplate. And as I said, that just goes away. So, if you remember our driver class, it looks sort of like this. This is a truncated version. Test classes, argv. What does that do? This allows you to do this. If you're not familiar with this double dot right here, for historical reasons, it's called the Aristotle. That's because Aristotle suggested this, by the way. Anything after this is an argument to your t/test.t. This is baked into prove. This has nothing to do with test pass most, but this allows you to pass arguments to your tests and not to prove. So anything after the double colon, well, these are the test classes we're going to run. This allows you to run an individual test class if you wish to. If argv is empty, it will run all of the test classes for you. So as you're testing, you can just test just like normal, type prove, the driver file, : name your class. I make this into a little tool mapping directly inside of my Vim, so I hit (T), boom, my tests run just like normal. And you don't even notice it after a while. So before I go further, does anyone have any questions yet? Was there anything I rushed through too fast? Okay, I thought that was pretty straightforward. So we use nested tap for our output. This solves a huge number of problems. So if you're not familiar with nested tap, this came out in test builder, I don't remember the exact number. Basically, I wrote what's called a subtest. And so I wrote it, Shorn fixed a lot of the bugs in it, and now it's available in test builder. And if you use a newer enough version of test builder, you can write subtest block and group a logically related set of tests. So for our nested tap, what we have at the top level represents all of our test classes. Indented, one level, is all of our test methods. And then inside is the individual tests within each method. So it's 3 levels of nesting. This allows you to have a conceptual grouping of your tests, which is very clear, and gets rid of a lot of the cruft in the original test class, which was trying to hack around the fact you didn't have this logical grouping that was there. And now at the bottom, because I requested some basic statistics be output at the end of my test run, I see the number of test classes that have been run, I see the number of test methods that have been run, and I see the total number of tests which have been run. If you use subtests already, you know you don't get this information. If you have 273 tests grouped into 5 subtests, you just see 5 tests have been run. Here, you will see all of the tests that have been run. And of course, the normal stuff down at the bottom, okay, all tests successful. Plans are handled rather interesting. At the top, we have a plan called, plan 1, : 1. That's because we only have 1 test class. So you don't need to write down any plan information anymore in this system if you don't want to. We know how many test classes we're running, so because it's a subtest, we can assert a plan at the top level saying, we're going to run X number of test classes. At the next level, we only had 1 test method in our test per person, so again, we can assert a plan of just 1 test. Very simple. Here, the 1: 2 after these tests, here we use the done testing facility within the subtest, so you don't have to worry about writing a plan even in your subtest. So as far as you're concerned, plans go away. So I got a bug report, so you can have plans if you want them. So I put that back in there. And the way this works is anytime you have code like this, you just assert the number of plans inside of this block. This means if you have a moose modifier saying around, after, or before for a particular test method, and this moose modifier also provides some tests, then again, you just have report plan, specify the number of tests in that modifier, and internally, test class moose will see how many tests you were supposed to run, compare that with the number of tests you did run, and you will get a failure if the number is incorrect. You can put it at the bottom if you want, it doesn't matter. This is because the way moose modifiers work, we cannot assert a plan before it runs because we cannot get the plan information yet. So you have the safety of plans if you want them, but you don't need them. I don't use them inside test class moose when I'm running it because I got the done testing and I feel comfortable with that. So again, so far everything, as much work as I can take away from you and just get you running tests has already been done for you. But let's talk about subclassing. This is where everyone starts breaking down with test class and extra style testing. And once you get over this hump, everything's golden. First of all, does anyone have any questions? You are such an easy audience.
Anyone use the same method modifiers as with test class?
Oh, you mean the attributes?
Yeah, which ones together?
Like colon tests?
Colon tests and...
No, that does not exist. I've been looking, he asked, do you use the same method attributes? Are they available, the same ones that you have in test class? I have considered writing some code, maybe a role, making legacy attributes available so that people can easily port them from the old to the new, but I haven't done that yet. I just haven't had a lot of time. But if anyone's interested in doing that, I would love to see a patch for it. It's on GitHub. So no, you cannot do that, but attributes are available, but they're used for something else, and you'll see those soon. Oh, subclassing. So, I'm sure I'm doing awesome on time. Yes, not a problem. So, we have a person-employee subclass of person. It extends person, and all it does is it adds an extra attribute called employee number. Again, simple, nothing complicated. This is just an example. One thing to keep in mind when you're writing object-oriented code is, as a general rule, if you have a class, if you have an instance of a class in your code, if you drop in a subclass of that instance, the code should run just the same. It should not break. So if you have a foo and you replace that with a foo subclass, your code should still be correct. It's very important. It's called the Liskov substitution principle. There's a little bit more involved with that. I recommend you look up Barbara Liskov and some of her work. It's really brilliant. So we keep this in mind when we're doing testing with inherited tests, because this means any tests that I wrote for tests for person should automatically be valid for tests for person employee. If they're not, then you have violated the Liskov substitution principle. There are ways you can deliberately violate it if you want to. But basically, I didn't write any tests here. Instead, I've simply had my person employee class extend test for person. And what happens when I run it? Boom. So this fails because you remember earlier when I showed you that we had hard-coded the class name person in there? This is a very common problem with test classes that I would like to see go away. The object constructor return isn't a person employee, it's a person. So you see exactly what sort of failure that you got. But notice we didn't write any tests. But these are tests for person employee because person employee inherits the test from the person class. So if I have a subclass of a class in my regular code, my test should have a subclass test of the parent test. Have you followed me so far? Does that make sense? Yeah. Cool. So basically, as much as possible, I like to see your test classes mirror your classes. The structure should be more or less the same. It makes it much easier to organize and follow your code this way. So how are we going to fix this? So this was our first test class. You saw that we had the person right there. But we actually have the class name right here. So I could replace this with test class name. And you might wonder if that's going to pass, and in reality it won't, and I'll explain why in just a moment. So we have several strategies for trying to figure out how to fix the inherited test problem. Again, this is what breaks everyone's test classes all over the place. You could override the test constructor test that we had. So note, this is called test constructor. So you could override that if you wanted to, but that's not really good because you want to inherit those tests. You want your code to assert that the parent tests are going to behave the same for the subclass. So maybe I don't want to inherit for test for person. Fail. But I see that a lot in test class code. They do this all the time. Oh, my test inheritance isn't working, so I'm just not going to do the inheritance, and therefore I'm either not going to get those tests or I'm going to cut and paste the tests. And I just fixed a lot of that in the current code base I've been hacking on. It's real fun. Or you can instantiate your object correctly, and I will show you one strategy for doing that. There's many ways you can go about it. But let's just have a quick review of where we are first. We have written two test classes. We've written two classes. We have written two test classes for them. We have seen test inheritance, but it wrote our test. So, anyone have any questions yet about anything?
I do, I think I'm going to leave class name.
Okay. Yes?
Use test class name.
I'm sorry, I can't hear you.
I think that you need to use test class name. Yes. That's part of the instantiating correctly.
Hmm?
You need to use test class name.
Instead of the hard-coded person. Yes, that's
Yes.
one of the ways of doing
That
it.
is part of the fix for it. But there's another part of the fix. So, one thing a lot of people fail to notice when they're writing tests, they're just hacking their code. They're hacking, and they might beautifully refactor their real code, but their test code is just kind of slopped together. And there is a key difference between test code and regular code. Your regular code is just sitting there. It's not doing anything until you're actually running it on production. Your test code has data. This is what makes it hard. We talk about fixtures. We talk about how to manage fixtures. We talk about all sorts of complicated issues with this, which I won't even go into. But your test code has data, which makes it fundamentally different from your actual code. And you don't want your code to be sloppy, so you got to consider this difference in your code. So in this case, separate the data from the code. The problem was in your test for person employee class, you actually had, you might remember, or in the person employee class, you had an employee number that was required. So when you instantiate the object here, if class name is person employee, that's going to fall down and go boom, because constructor args doesn't have an employee number. However, as you pointed out, we now have test class name, so that's part of our fix. And by separating the data from the actual code, in our test for person employee, around constructor args, because hey, this is Moose, we've got all the Moose available, we return our original constructor args, and we add on this new thing for the constructor arg employee number. You can do this any way you want to. I could have just actually made this a regular method and called, my args equals self parent or self next method, and then added the employee number. However you want to do that. I'm just showing you here that all of Moose is available. So in our subclass, we call next method report. We assert a plan of one because this test constructor has overridden the test for person test constructor. We now call the next method with our report object, which goes up the call stack to test for person, or up the inheritance stack for test for person, runs that test method, and then we add a plan of one to show we have one more test right here. And we test that our employee number is correct. And now our tests pass. Great. We finally got a passing test suite. We're beginning to use test inheritance correctly, but we're still not quite there because we constructed the object twice. We constructed this in test for person. We constructed the object again in test for person employee. And do you really want to keep rewriting that boilerplate code for every single method? No, you don't want to do that for many reasons. One, it's carpal tunnel. Two, you don't like to keep repeating yourself. These are tests, but they're code, and code needs to be treated well. So instead, let's stop constructing that object over and over again inside of every test method. When you run a test suite, I'm going to extend this a little bit, but I haven't done it yet. We have what I call test control methods. These are for different phases of every test class. You have before the class runs, after the class runs. Before the test method runs, after the test method runs, and that's before and after each and every test method. So we have test underscore startup will run before your test class. Test setup before every test method, test teardown after every test method, test shutdown after the test class. What do we use these for? Well, in the startup, we might want to connect to our database. In our setup methods, we often start a transaction in our setup, we run our test method, and then we roll back the transaction in our teardown method. So that way we just have nice, safe transaction code. We don't have to worry about that. Our shutdown method at the end of the class might go through and clean up extra test files or data files that we've created or whatever. I intend to extend this beyond what test class has. I'm going to have a test suite begin and test suite end so that you can connect to the database at the beginning of the test suite instead of the beginning of every test class and instead of using some of the hacks that people have been using. So there's plenty of reasons why you use these. And right now, we're going to create like a small fixture, sort of. In our test setup method, you may remember test setup runs before every test method. The first thing you do in any test control method If it's a startup or setup, you call next method, I should have passed report in there. You call next method so you get your parent method. So if there's any parent construction going on, then you need to get that. And then we instantiate our test person object. And note, we have an attribute. Test person is a read write, is a person. Excuse me for a moment. Please note that I said earlier that every test method that begins with test underscore is reserved for test class moves. So you might be wondering, what does that mean? That doesn't mean anything, because that's an attribute, it's not a method. So if you want to have it test underscore, this is perfectly fine, and that will, the test class moves is going to ignore that. You can use attributes any way you want to. So in our test constructor class for person, we now test that our test person, we should have a test person. Great. We now know that our test setup method created a person for us. At the beginning of every test that we run, we will have a brand new person object to play around with. I might add, unlike test class, inside the test control methods of startup, setup, teardown, and shutdown, you cannot run tests, and it will throw an exception if you attempt to do so. Hard, that is great. Yes?
On the previous slides, the method was called like last name, now it's like less test. Are these synonymous?
That's a bug.
Okay.
What he asked was, why is this now called class to test instead of class underscore name? This is because partway through writing that role a long time ago, I had changed the method from class to test to class name because it was just easier to read. And I forgot to change it again, so thank you. I will change that in the next version of my slides.
Usually in a spec and another test frameworks.
I'm sorry?
Usually in other test frameworks it is named subject, not test object, but subject.
So, what name would you suggest?
Has test person. It must be has subject. Test subject.
Okay, that might be a better way of going about it. I'm not sure how much people are using this particular role inside of production yet, so I'd have to give that some thought, because I really dislike the thought of breaking backwards competitively. But thank you. So, yes?
Maybe one more question. I'm not really sure what the next column method does. Can you explain a bit?
I'm sorry, this?
Yeah, this line. Yeah.
Okay, so in these test control methods, before each class, for each test method, before each, after each test method, after each test class, imagine your test startup method. At the startup method, inside of your base class, you connect to your database. Very handy, very useful. You want to connect to a database because otherwise you can't run your database test, presumably. You have a subclass, which also has a startup method. And this startup method maybe connects to Redis instead of your database. But it has to call the parent version, and in this is effectively the same thing as test super, whatever. It has to call the parent version of that method in order to guarantee that the database connection will still be available. I had considered the possibility of doing that for you so you didn't have to do it anymore, but I decided in this case to make this step manually explicit, even though it's a source of bugs, because it may be the case that you want to say, in this particular instance, I do not want to call my parent test control method.
Okay.
So you always call these for startup and setup, you call those before you do this in order to make sure if this needs anything, such as a connection to the database, for example, that it's going to be available for you. In your teardown and shutdown methods, you will call next method after you do your personal teardown. Does that make sense?
Yeah, sure. Thank you.
Okay. Now, in our test for person employee, note, we don't have a startup method here, or a setup method here. What happens to test class moves is going to go through here, and it's going to see that you've inherited a test setup method. Because you have not overridden it, it will call your parent test setup method for you, and you will get your test person object here, just as you expect. And your constructor args method there is just to make sure that you have your employee number handily available. So again, it's a little bit more duplicate code, which goes away by proper use of test control methods. So are you with me so far? Anyone have any more questions at this point? Yes?
Not here.
It's generally considered a code smell to have duplicated class hierarchies. Does that apply here too with tests, or do you simply not agree with that?
Do you mean duplicated class hierarchies? How? Can you give me some context in this case?
The context in this case is that you recommended that your test classes inherit in the same way as your tested classes.
Yes, and I do not consider this a code smell in this case. What he said is basically it's considered to be a code smell if you have duplicate class hierarchies.
Right.
And I would say, yes, this is absolutely true if you're looking inside your lib directory and you see a bunch of duplicated class hierarchies, there's an opportunity for refactoring there. Refactoring a regular class against a test class is a very dangerous thing to do because this implies that you might be mixing up some of your test code and your actual code. These are separate.
Yes.
So this is a case where, yes, it is a code smell, but it is not a code smell in the case where you have a set of tests mirroring a set of actual classes.
So it's an exception because it's two kinds of code, testing code and
Yes, these are fundamentally different types of things.
okay, fair enough.
So,
Thank you.
So I think that leads quite nicely into the question out of the back of my mind, which is sort of a couple of one or two directory levels up with tests for how do you lay out your code? Is tests for in lib or is it in t lib or how do you
generally speaking, if you put them in lib, you're going to have your tests installed
That was
with
what
the
I
code.
was- yeah.
And I know there are some people who actually like this idea because they like the idea that later on they could run their tests along with their code. I'm not going to advise for or against that. I put my test for inside of tlib, and I have a tlib test for directory, and then I have a tlib, and then maybe some utility classes or modules to keep them separate from my test classes. Does that make sense?
Yeah, that's perfect.
So there's some controversy about the best way of handling that. So getting back to our first test class, same thing as before, everything runs just fine, except you will note, okay, I did not show the example of using plans. This plan might be generated if you've done testing, but if you put the plan assertions in there, then it will be generated from calculated from your actual plans, and that will be otherwise. So we now have one test class, we have one test method, and we have a total of 4 tests run just for person employee because that's all we've run. Because presumably we did prove t/test.t : test for person employee. And then if you run the entire test suite without verbose mode, we can see that, so it says 3 tests because that's what prove or test harness thinks we actually have. But that's because we have 3 test classes. The reason we have 3 in this case is because you have that base class that I showed you earlier, which doesn't actually have tests. I'm not sure if I want to eliminate that from this count or not. But you have 3 test classes. You have a total of 2 test methods runs, the one in your subclass, one in your parent class, with a total of 7 tests run all together. So this is some of the, just a little taste of some of the reporting capabilities which are available in this. So at this point, does anyone have any more questions?
Yes.
Are you going to have a slide later on showing failures and what kinds, or is that completely dependent on your own testing code? No built
Didn't I say earlier you couldn't ask questions?
No, you said I couldn't heckle.
Is there a difference? No, seriously, what kind of failures do you mean?
I just mean, all your examples so far show tests passing, but...
No, I'm sorry. Maybe I went too fast past the slide. Wasn't that delicate? So there's some normal test failure as a subtest because it's indented.
Oh, yeah, okay. Yeah.
Okay. Does everyone here know what subtests are? I explained them briefly, but does anyone have any questions on that point?
No.
Okay, good. They've been around for a while, so I think we're okay.
I have 2 questions.
By the way, how much time do I have left?
I have 2 questions. One question is, have an easy way to test attributes, new attributes, not only existing, but its properties, read-only, read-write, and other.
Oh, yeah, that's trivial because you just take advantage of the Musma. So, what's that?
15.
Okay, great. Yeah, I got plenty of time. So basically, you get your class and you call the meta method on that. This will get your meta object back, and then you just go through the like normal You know, okay, give me my attributes, give me all the information about my attributes, and you can make those assertions at that time.
And
So yeah, this isn't test pass moves, that's just straight moves you're talking about there.
oh, and this another question is to what your most robust way to mock objects and mock stuff and extra and moves.
Let's talk about that afterwards, because that is a long, contentious debate in many ways, and this is well beyond scope of this talk, but it's a great question.
No best practice.
7 or 8 different ways.
Yes, there are 7 or 8 best practices on how to mock an object appropriately.
What's your favorite this week?
I like dependency injection.
What?
Something called dependency injection, which never turn on your phone like this.
Answer it and tell them you're in the middle of a talk.
Yes. So, yeah, I use dependency injection, which is really trivial, particularly with Moose, but I'm not going to go into that right now. So, using a setup method, we've already been here. First test class, going to test suite, tags. Now we're going to start getting some of the stuff which is well beyond the scope of what pretty much anything else for Perl is offering you right now. Anything else for Perl which is based upon, you know, a lot of the standard tools that we're already familiar with, that is. So, prior to what I'm doing right now, I work for a company in Paris that had a lot of construction going on outside. And more than once, we'd come into the office and our network was down because someone had, again, cut through a cable. The French are very, very good at finding cables and cutting them. It's like a skill. I don't know what it is. And our test suite wouldn't run. Some of the tests would block, some of them would just fail because, hey, we don't have a network connection.
Answer it!
Your phone does have a network connection.
Hello. I'm going to have to call you back. I'm in the middle of a talk right now, but thank you very much. We'll be down later. Yes, thank you very much. Bye-bye. Sorry.
So who's on fire?
No, it's someone I gave my business card and they were supposed to call me today and they in fact did. So I'll have impeccable timing. Okay, so as I was saying about the French, my wife is French, I won't diss them too much. The cables get cut all the time. But we'd have various tests fail or tests block because we didn't have a network connection. This was very annoying. And I often wanted a way of saying, just run all the darn tests which don't have a network connection, which require a network connection. If you're familiar with how tests work in Perl today, this is very hard to do. No, it's not. Just tag it with network. Well, of course, you've got to be using test class Moose. So you tag it with network, and what do tags do? In your constructor, you can say include tags network. This will run only your network tests. Any test tagged with network, any test not tagged with network, this will not run the tests. So this is a fine way of picking out which bits of your test suite you want to run. Or you can exclude the tests. This will run all of your tests except for those methods tagged with network and database, or DB. So now you can say, these are all unit tests. These are all API tests. This gets really interesting, by the way, because when I'm running test coverage, I want to exclude my unit tests. Because a lot of times unit tests will be testing dead code, and you're like, yay, I got 100% coverage. No. So if you exclude your unit tests and you run code coverage, you get much better code coverage because you're finding out what your API tests, your full level integration tests are actually testing. And then you say, why aren't my tests actually covering this little bit down here? Well, that's really interesting because then you might find out that you can't actually reach that code, but otherwise you might have written tests for that code and you think everything's fine because you got 100% coverage. Yay! So this gives you all sorts of control over your test suite, of what you do want to test, of what you do not want to test. Network goes down, just start with a network test, whatever. Thank you. And in this case, for our driver, this is the fake network test we have. Pretend this test needs a network. Test for person. Only this test got run because the test something test is what was tagged with network. The other tests, which I admitted here, are not going to be run. So great. Now, all of a sudden we're starting to get some very interesting control over our test suite, something you just can't do otherwise. Like I said, I'm really happy with this feature. We also have multiple tags allowed, of course. If you want to tag something as a network test and a unit test, no, that doesn't make sense. I know, but just bear with me. Ovid needed coffee when he was writing that. But you know, you can have multiple tags, and as you say, use these tags or exclude these tags, you can control it that way. And here, so when you run the full test suite in verbose mode, and we're asking for specific tags, so my test class, well, didn't have any tests in there, and it simply says we're skipping the class because we can't find any test methods. Our test something, well, we had this network, and test for person employee, again, we had this tag, which had the network tag in there. Tags, this is a recent change made to test class menus. If I have a test underscore foo method, and a subclass of the test underscore foo method, it will inherit its parent's tags. But sometimes this is not appropriate because the internals have changed so radically. Instead of, you know, connecting to SQLite, you connected to Redis in your subclass, so you can just assert an empty tag block or just put in different tags, and this will replace your parent tags. Does that make sense so far? So I didn't document that up here, but it's something important to be aware of. So you can tag users, use them only to run your API tests, and that's a great thing to run your code coverage against, not your entire test suite. Only run your unit tests if you just want to run those. You know, oh, these are tests that I only want to run on a smoker. You know, maybe your Jenkins instance is saying, you know, I want to run these instead. You know, create fixtures only if the test needs it. You can actually do this now, but it's not documented, and I didn't do that because the API needs some work. So you could say, well, this test doesn't need a person object, therefore I'm not going to instantiate a person object. Skip the network test if the network is down. Oh my goodness, so many times I've wanted this. I have this all the time now on this laptop. I have a virtual machine where if I've got bad connectivity, sometimes it's trying to connect to CouchDB, and I don't want it to. So I have a hack in our current test suite to allow this. Next, reporting.
Yes, a question. Would it be possible to link a tag to a proof? I mean,
No, proof is completely agnostic.
no,
about all
proof,
this.
not the command proof. Like in a test in a skip block, you can run or not block if one condition gets okay or not. And would it be possible to link a tag only run this test if that anything is okay, like a ping?
Yes, you potentially could do that. It's all there because this is standard OO. So just you take a look at your base class and how you construct your base classes that you're inheriting from. That can control your behavior, and you can introspect the tags and say, you know, based upon this behavior, I do or do not want this behavior to occur. Or based upon this tag, I do or do not want this behavior.
Because in that
If you
way,
can do this in regular code, you can do this in your test code. Just always keep that in mind. Okay? Does that answer your question?
I'm not sure.
Maybe we can chat about this afterwards because I'm running a bit low on time now. But I do want to answer your question, but it's a good question. But yeah, you put that functionality in your base class. So, you have a long-running test suite. It takes about an hour to run. I see these all the time for larger organizations. It's very frustrating. There's all sorts of ways you can speed up your test suites, running them in a single process, forking off you know, multiple different instances, all sorts of techniques you can use. You know, stop asking for the same information from your database 20,000 times in a row, all sorts of things. But you might also want to know, if I can't get my test suite any faster, but it's really slow, which tests are slow? You know, sometimes it's kind of hard to do this if you're running coverage information. Have you ever tried to run develop cover on something which ordinarily takes an hour to run? Yeah, you're going to have a lot of fun with this. So instead, after you run your test, get your test report. So it works just like this. In this case, you don't have to run this in a subtest, but I'm doing this just to show you a hypothetical example where you're not just testing your test, but you're also going to test some characteristics of your test suite. We fetch our test report down here, and to do this, we run our full test suite in a subtest. And then I can say, report, give me all my test classes. Okay, give me the class name. You know, was this class skipped? And we assert that none of our classes should be skipped. You know, for all the test methods for this class, we get the method name, assert that the method was not skipped, assert that we actually had tests run for that method, and get a class time. Duration is a human readable string, but you can also get the numeric information if you just want to make an assertion that no test took more than X amount of time to run, so you can get all this information. If you have time high-res available, it will give you this information down to, I think it's at the millisecond level, something like that. So you can find out very quickly which my classes took a long time to run, get all sorts of information about your test suite, which may prove useful to you, particularly if you're trying to figure out why aren't these tests running, and then you run this and you're asserting for a particular method name, and you say, it's not run. Later on, I might want to put some more information, meta information about the reasons why I say something didn't run. Well, you asked for these two tags and this method didn't have it. But this sort of information is there, and you can run this. So here, I elected to run it as tests, which is why this was as a subtest. If you don't run those as tests, if you just want to print out report information, maybe save it to a database for information about how your test suite performed, you don't need to put that in a subtest. Just run your test and get your test report. Report objects. Report objects are for classes and for roles. I may put one for the entire test suite, or for classes and for individual methods. And it uses a reporting role, which has name, note, skip, to skip time. Notes is just a hash ref. If you just want to shove some notes in there, during your test, say notes, here's some information, store it, later on you can ask for it back. This time method down here is actually a time object, which is done with test class moose report time. You can get your real time, user time, system time, or a human readable duration if you just want to print that out. Gives you all sorts of information. If you see your real time, your system time, or diverging wildly, that can give you all sorts of interesting thoughts about, what's going on there? And so the summary of all of this, you get fine-grained control over your test suite and how it's actually performing, something you really don't have right now. It's a barrier I keep running into with tests. You get XUnit style testing, like you would with test class or test class most. You get full Moose integration for those of you who appreciate Moose. There's all sorts of interesting possibilities available with this. And you get that reporting information that you just didn't have before. And I would like to extend this more in the future. But this opens up interesting possibilities. Everything runs in a single process, so you say, well, how do I parallelize my tests? Well, that's an interesting question. Well, you have the get test methods, or the test methods method inside of a test class Moose, and you can use that to, let me see, you would add attributes to your various methods saying, I can run this in parallel, or I cannot, whatever, and then you can combine with this timing information to start front-loading your long-running tests, however you want to do it. You can override your get test method stuff, fork off a whole bunch of different processes, and each one's get test methods pulls in a different set of methods and runs along just like normal. I haven't actually implemented this yet. I'm waiting for someone to do it, but it's there, and it should be trivial in a way that, well, trivial for this sort of problem. My wife told me to put this slide in here, so I don't know. Anyone have any final questions before we're done?
There is no questions, but one thing. This embedded tab protocol is not standard. Tab protocol is standard, embedded tab is not.
And what tab is not?
Tab protocol is standard.
Yes.
Embedded tab is not standard.
Embedded as in
Yes.
So it cannot be passed by typical Jenkins tab parser.
Jenkins can read nested tab.
Huh?
We use it. Jenkins can cope with nested tab.
Yeah?
When I designed nested tab, one of the things I did was the bottom line after the indentation is a summary line for the above test. So even if you can't read the nesting, that summary line will tell you if that subtest passed or failed.
Already supported that.
So I'm running out of time. I have about a minute left, so we can talk about this afterwards.
Okay.
You are right and not right in different ways. It's a complicated situation, which I'd love to chat with you about. There's some issues with the parser for actually getting this information available. It's a harder problem than people think. But the overall pass-fail, which is what you primarily want, is available there. And for test class Moose, I've got a little bit more information available because I wanted that at the test suite level. So, sorry, if you have any questions, please feel free to stop me in the hallway and ask me afterwards. I am out of time.